A perpendicular bisector is a line which goes through another line at right angles and cuts it in half. The perpendicular bit means right angles, and the bisector part means cuts it in half. These diagrams show two perpendicular bisectors. One is for triangle ABC, and it's the perpendicular bisector of side AB, where we find the midpoint M, and then we're drawing in our perpendicular bisector. So you can see that both sides of the midpoint are equal. And in triangle PQR, our midpoint is M again, and it's bisecting side PQ, where we're drawing in our perpendicular bisector. So the steps to find an equation of a perpendicular bisector are, firstly, find the midpoint of the line in question. So for this triangle, it would be AB. For this triangle, it would be PQ. Then we're going to find the gradient of that line, which is going to be our M1 value. Then we're going to find the perpendicular gradient, M2, using our relationship M1, M2 equals -1 for perpendicular gradients. And that will give us the gradient of our bisector. And then we're going to substitute in the midpoint and that gradient of our perpendicular bisector into our equation of a straight line, y minus b equals m upon x minus a, to find the equation of our perpendicular bisector. Something to note when finding perpendicular bisectors of a triangle, the third vertex, so in this case it would be C, and in this triangle it would be R, are totally irrelevant to any calculations. So let's try an example. The triangle ABC has vertices 0, 2, 4, 2, and -2, -2, and we want to find the equation of the perpendicular bisector of AC. So step 1 was to find the midpoint of AC. So we're going to find the midpoint, and we're going to use a capital M of AC, and that is going to equal we're going to add our x coordinates together, so 0 plus, and remember we're not using b at all in this calculation, -2 divided by 2, and our y coordinate is going to be 2 plus -2 divided by 2. And that's going to give us -1, 0. Now for this particular one, since there's a diagram on a Cartesian grid, we could have actually just read that off, but we can just double check that our calculation lines up with what's actually on the diagram. So step 2 was to find the gradient, so little m of AC. And that is the difference in our y coordinates. So we're going to do 2 take away -2, and the difference in our x coordinates. So we're going to do 0 take away -2. And that gives us 4 divided by 2, which is 2. Now, step 3 was to find our perpendicular gradient. Now, our relationship was m1, m2 equals -1. So our perpendicular gradient is going to equal the reciprocal of MAC, which is a half, and then we have to change the sign to -1/2. Now, final step, to actually find the equation of our perpendicular bisector, we're going to write our equation of a straight line, y minus b equals m upon x minus a. And then we're going to substitute in our midpoint and our gradient. So we've got y take away 0 equals -1/2, and then we've got x, and it's -1, so it's going to be +1. Now remember, we don't like fractions at higher, so we're going to get rid of that divide by 2 by multiplying this side by 2. So we're going to end up with 2y equals, and then multiply out our brackets, negative x, take away 1. Now, that's a perfectly valid answer, or we can gather everything over to the left-hand side, 2y, then we need to add on the x, and add on the 1, and that equals 0. And that gives us our equation of the perpendicular bisector of AC. So, fun fact, 3 perpendicular bisectors of a triangle meet at a single point, so we say that they're concurrent, and this point is called the circumcenter. But that's not something that you need to know for the exam. So classwork, exercise 1.6, questions 1 ACE, questions 2 and 3, and then if you want to try some more of the exercise, then feel free to do so. Any problems, let me know.